nomenclature is a set of rules used for naming compounds. And there are a lot of compounds that many people can look at the formula and already know the name just because we've seen it so many times in the course of our years going to school. And the first one up here on the board is NaCl, which is sodium chloride, also known as table salt. The second compound up here, HCl, is hydrochloric acid. Another compound that many people might be very familiar with. And the third one up here is carbon dioxide. Now, each of these three substances is a little bit different. NaCl is an ionic compound, which is formed by the attraction of a sodium ion to a chloride ion. In an ionic compound, just to review, we have a complete or almost complete transfer of electrons. This compound obviously is an acid. And starting with H, it's pretty common that acids will start with H. And then the third compound is carbon dioxide. And carbon dioxide is a molecular compound or covalent compound, which means that the electrons in the bonds are shared as opposed to transferred like they would be with an ionic compound. And the rules for naming each of these different types of substances is different. So when you're learning how to apply a name to a formula, the first thing you need to do is differentiate between the types of compounds. Is it an ionic compound? Is it an acid? Or is it a molecular compound? Now, the first types of compounds that we're going to look at will be ionic compounds. Now, rules for naming an ionic compound, which typically we're going to have a metal and a nonmetal in an ionic compound, or a metal with a polyatomic ion, or a polyatomic ion with a nonmetal. So if there's a polyatomic ion in the formula, then we know that that's an ionic compound. So the first type of compounds that are ionic in nature that we're going to take a look at are called binary compounds. Bi means two. A binary compound means there are only two elements in the compound. When there are only two elements in the compound, the anion is going to end in IDE. The next question we're going to ask ourselves is, in this binary compound where there are just two elements in there, let's take a look at the metal. Is the metal part of group A, or is it part of group B? Of course, group A is going to be metals that are going to be located on the periodic table in the S and P sublevel for the most part. And the group Bs typically are going to be the transition metals and possibly a couple of other elements that live in the P sublevel on the periodic table. And students have been provided with a list of the group B metals and their possible different charges. We're going to start with the group A metals for right now. These are probably the easiest. If the metal is a group A metal, then all we do is name the ions. So, for example, NaCl, as I said before, is going to be sodium chloride. And that would be a chloride ion once it's gained an electron and gotten a charge. Now, if the metal happens to be a group B metal, We know that the group B metals, the transition metals, tend to have more than one possible charge attached to them. And so we're going to do the same thing in terms of naming the ions and making the non-metal, changing the ending to IDE, but we also have to use Roman numerals to indicate the charge of the particular ion. Now the example that's given down here is CuCl2, and the name is written copper 2 chloride. Well, copper can be +1 or +2. So I need to look at the formula to determine which of those copper ions do we have in this compound. Now, since I know that chlorine always forms an ion with a -1 charge, and there are 2 chlorines in that compound, that means that on the chlorine portion of this compound, I have a -2 charge. Now the copper, there's only 1 copper in there, and I know that the copper and the chlorine, their charges need to balance out and add up to 0 to form a neutral compound. So if I have 2 chlorines, each with a -1 charge, and I have 1 copper, that means that that copper must be copper +2. Here I have a +2 on the copper, a -2 on the chlorides, giving me a neutral compound with a net charge of 0. The other way to look at this is in the shortcut that we learned. If we had copper 2 chloride, that would mean copper with a +2 charge, chloride with a -1 charge, and when we crisscross the charges and we bring the 2 down and we pretend to bring the 1 down, we end up with CuCl2. So the 2 came from the copper +2. So it's very important to remember any element, any metal that has more than 1 possible charge, we need to indicate which ion it is by using the Roman numerals in the parentheses in the name. So for a little bit of practice, we already talked about NaCl. But we'll talk about the next one here. This is Kf. So it is a binary compound. I know that there are 2 elements in there, and potassium is a group A metal. It happens to live in group 1 on the periodic table. And fluorine, of course, we're going to change the ending to IDE when it becomes a fluoride ion. So the name would be potassium fluoride. Okay, same thing with this example. Lithium and iodine are going to form lithium iodide. Lithium is a group A metal, also in group 1 on the periodic table. So we would change the iodine when it becomes an ion to iodide, lithium iodide. Next example, we have an aluminum with 3 bromines attached to it. Aluminum is a group 1 metal, and we're going to change the ending to IDE, giving us aluminum bromide. Now, over to the other side here, FeCl3. Fe, iron, is one of my transition metals, and I know that iron can be +2, or it can be +3 in terms of its ionic charge. And in this instance, I know that the iron is going to be +3. Why? The 3 came from the iron. Or to put it all the way out there and write the entire thing out, if we have 1 iron and 3 chlorines, and each chlorine has a -1 charge, and I know that these charges must add up to 0 to form a neutral compound, Then the chlorines add up to a -3, which means the iron has to add up to a +3, and there's only one iron in this formula. So in that instance, the name for this compound would be iron 3 chloride. And now we'll take a look at ternary compounds. Ternary compounds have more than 2 elements in there. So there'll be 3 or more elements in a ternary compound. And as such, that means that they will contain polyatomic ions, which is why we had to memorize the list of polyatomic ions so that we can very easily recognize them when we see them in a compound. So the rules again are going to be similar. Is the metal a group A metal? If so, just name the ions. For example, MgSO4. Magnesium is a group A metal. SO4 is the polyatomic ion. SO4 -2 is the polyatomic ion sulfate. So the name of that compound would be magnesium sulfate. If the metal is a group B metal, the rules will be the same. In that, we need to determine the charge of the ion in the compound and write the charge in Roman numerals and parentheses to tell us what particular ion that was. So for example, okay, here is copper, a group B metal. I know copper can be +1 or +2. And I know since the polyatomic ion that it's bonded to in here is nitrate, if I break this down, I have 2 nitrates in there and one copper. Okay, so if I have 2 nitrates in there, then that means the total charge on the nitrates is a -2, which means the total charge on the copper has to be a +2. So we would write that out as, we would write the name of that compound out as copper 2 nitrate. So here I have a few examples of ternary compounds. Starting with the first one, we know that the metal is aluminum. And we know that aluminum is a group A metal, and so we do not need to distinguish between any different types of charges. Aluminum is always a +3. And the polyatomic ion that it's bonded to is sulfate. Sulfate SO4 -2. So the name then would simply be aluminum sulfate. The next example, I have copper. Now copper can be copper 1 or copper 2. In this instance, we have it bonded to the polyatomic ion hydroxide, which is OH-. And in the formula, there are 2 hydroxides. Okay? So if there are 2 hydroxides, the hydroxides give us a total of a -2 charge, and we know that the copper has to add up to +2 in order to make this a neutral compound. And since there's only 1 copper in the formula, then that must be copper +2. So we have a +2 - 2 = 0. And so when we name this compound, we would indicate that it was copper